fire detection alarm panel must be upgraded to Class A from Class B if major renovation work is being done. Major renovation work, in this context, includes cable, conduit, and the panel itself. The question revolves around whether upgrading the fire suppression system necessitates a fire detection alarm panel upgrade from Class B to Class A. Based on the information, the renovation focuses solely on the fire suppression system. Fire detection alarm panel itself is not undergoing any alterations. Therefore, a direct upgrade to Class A for the fire detection alarm panel is not explicitly required solely due to the fire suppression system upgrades. However, a critical caveat exists. If the fire detection alarm panel requires any additional wiring modifications, even for minor zone changes, this new wiring must adhere to the stringent requirements of Class A fire detection alarm systems. This adherence extends to physical separation. The new wiring for the fire detection system must be installed in a separate conduit completely isolated from the wiring associated with the fire suppression system. The distinction between Class A and Class B fire alarm systems is crucial for understanding this requirement. Class B systems, often described as a star architecture, typically involve a two-wire configuration. This means that initiating devices such as smoke detectors and pull stations are wired in a branching fashion from the fire alarm control panel. A single break in the wire can disable an entire zone or branch of devices. Class A systems, on the other hand, employ a loop architecture, often requiring 4 wires. The circuit originates from the fire alarm control panel, travels through all initiating devices in a zone, and then returns to the control panel. This loop configuration provides a higher level of survivability. If a single break occurs in the wiring, the circuit remains operational because the signal can travel in the opposite direction. The requirement for separate conduits in Class A systems is intended to further enhance survivability and reliability. By physically isolating the fire detection system wiring from other systems, such as the fire suppression system, the risk of simultaneous damage is minimized. For instance, if a fire-related event were to damage the conduit containing the fire suppression system wiring, the separate conduit containing the fire detection system wiring would be less likely to be affected, ensuring that the fire alarm system remains operational to provide critical alert. The installation of fire alarm systems and the interpretation of relevant codes and standards often require the expertise of qualified professionals. Fire alarm system designers, installers, and inspectors must possess a thorough understanding of the applicable codes and standards, as well as the specific requirements of the building and its occupancy. These codes and standards can vary depending on the jurisdiction and the type of building. The National Fire Protection Association, or NFPA, is a widely recognized source of fire safety standards. NFPA 72, the National Fire Alarm and Signaling Code, provides comprehensive requirements for the design, installation, testing, inspection, and maintenance of fire alarm systems. It is crucial to consult the latest edition of NFPA 72 and any applicable local codes when working with fire alarm systems. The selection of the appropriate class of fire alarm system, whether Class A or Class B, depends on several factors, including the size and complexity of the building, the occupancy type, and the specific requirements of the local fire code. In some cases, a Class A system may be required by code, while in other cases, a Class B system may be acceptable. However, even if a Class B system is permitted, it is often advisable to consider the benefits of a Class A system, particularly in buildings where a high level of reliability is essential, such as hospitals, schools, and high-rise buildings. When making any modifications to a fire alarm system, it is essential to obtain the necessary permits and approvals from the local fire marshal or other authority having jurisdiction. These authorities will review the proposed modifications to ensure that they comply with all applicable codes and standards. It is also important to ensure that all work is performed by qualified and licensed professionals. In summary, while upgrading a fire suppression system alone does not automatically trigger a Class A upgrade for the fire detection system, any additional wiring to the fire detection system necessitated by the fire suppression upgrade, even for zone changes, must adhere to Class A standards, including separate conduit installation. Always consult local codes and qualified professionals for specific guidance. It is important to consider the implications of the changes in fire safety and the coordination required between various building systems. For instance, the activation of the fire suppression system might trigger specific actions in the fire alarm system, such as silencing audible alarms in the immediate area of the suppression activation while maintaining the alarm signal at the fire alarm control panel and notifying the fire department. This level of integration requires careful planning and programming to ensure that the systems work together effectively to protect the occupants and the building. Another critical aspect of fire alarm system design and installation is the proper selection and placement of initiating devices. Smoke detectors, heat detectors, and manual pull stations must be located in accordance with the applicable codes and standards to ensure that they provide adequate coverage and early warning of a fire. The type of detector used depends on the specific hazards present in the area being protected. For example, smoke detectors are typically used in areas where smoldering fires are likely, while heat detectors are often used in areas where flaming fires are more common, such as kitchens and mechanical rooms. Regular testing and maintenance are essential for ensuring the continued reliability of fire alarm systems. NFPA 72 provides detailed requirements for the inspection, testing, and maintenance of fire alarm systems. These requirements include periodic testing of all initiating devices, notification appliances, and control panel functions. The frequency of testing depends on the type of device and the specific requirements of the local code. It is also important to maintain accurate records of all testing and maintenance activities. These records can be used to track the performance of the system over time and to identify any potential problems. In addition to regular testing and maintenance, it is important to provide adequate training to building occupants on how to respond to a fire alarm. This training should include instructions on how to evacuate the building safely, where to assemble after evacuation, and how to report a fire. Fire drills should be conducted regularly to familiarize occupants with the evacuation procedures. The fire alarm control panel serves as the central hub of the fire alarm system. It monitors the status of all initiating devices and notification appliances, and it initiates the appropriate responses when a fire is detected. The fire alarm control panel must be located in a secure area that is accessible to authorized personnel only. The panel should be clearly labeled with the name and address of the building, as well as the phone number of the fire department. It is also important to ensure that the panel is properly grounded and protected from power surges. Notification appliances, such as audible alarms and visual strobes, are used to alert building occupants to a fire. The type and number of notification appliances required depend on the size and configuration of the building, as well as the occupancy type. Audible alarms must be loud enough to be heard throughout the building, and visual strobes must be visible to occupants with hearing impairments. The placement of notification appliances must be carefully considered to ensure that they provide adequate coverage and that they do not create a hazard. For example, strobes should not be placed in areas where they could cause disorientation or seizures. The integration of fire alarm systems with other building systems, such as HVAC systems and elevator systems, can enhance the overall safety of the building. For example, the fire alarm system can be programmed to shut down the HVAC system to prevent the spread of smoke throughout the building. The fire alarm system can also be programmed to recall elevators to the ground floor to prevent occupants from becoming trapped in the elevators during a fire. This level of integration requires careful planning and coordination between the various building systems. When designing and installing a fire alarm system, it is important to consider the specific needs of occupants with disabilities. The Americans with Disabilities Act, or ADA, requires that fire alarm systems be accessible to people with disabilities. This includes providing visual notification appliances for people with hearing impairments, as well as audible alarms that are loud enough to be heard by people with hearing aids. It is also important to ensure that evacuation routes are accessible to people with mobility impairments. The selection of wire and cable for fire alarm systems is critical to ensure the system's reliability. Fire alarm cable must be listed and approved for use in fire alarm systems. It must be resistant to heat and flame, and it must be properly installed and protected from damage. The size of the wire must be appropriate for the amount of current it will carry. The color of the wire must be in accordance with the applicable codes and standards. Conduit is used to protect fire alarm wiring from physical damage and to provide a fire-resistant pathway for the wiring. The type of conduit used depends on the specific application and the requirements of the local code. Metal conduit is typically used in areas where the wiring is exposed to physical damage, while non-metallic conduit is often used in concealed locations. The conduit must be properly installed and supported to prevent it from sagging or becoming damaged. Grounding is essential for the proper operation and safety of fire alarm systems. The fire alarm control panel and all initiating devices and notification appliances must be properly grounded. The grounding system must be in accordance with the applicable codes and standards. A properly grounded system helps to protect the equipment from damage due to power surges and electrical faults. It also helps to reduce the risk of electrical shock to occupants. Surge protection is used to protect fire alarm systems from damage due to power surges. Power surges can be caused by lightning strikes, power outages, or other electrical disturbances. Surge protection devices are installed at the fire alarm control panel and at other critical points in the system. These devices divert the surge current away from the sensitive electronic components of the system, preventing damage. Battery backup is essential for ensuring the continued operation of fire alarm systems during a power outage. The battery backup system must be capable of providing power to the system for a specified period of time, typically 24 hours. The batteries must be properly sized to meet the power requirements of the system. They must be tested regularly to ensure that they are in good condition. Documentation is essential for the proper maintenance and operation of fire alarm systems. The documentation should include a complete set of drawings showing the location of all initiating devices, notification appliances, and control panel components. The documentation should also include a detailed description of the system's operation, as well as a schedule of testing and maintenance activities. The documentation should be kept in a secure location and made available to authorized personnel only. It is crucial to maintain clear communication with the local fire department regarding the fire alarm system. The fire department should be notified of any changes to the system, as well as any planned testing or maintenance activities. The fire department should also be provided with a contact person who is familiar with the system and can respond to any questions or concerns. When troubleshooting a fire alarm system, it is important to follow a systematic approach. Start by checking the fire alarm control panel for any trouble indications. Consult the system documentation to understand the meaning of the trouble indications. Use a multimeter to test the wiring for continuity and voltage. Inspect all initiating devices and notification appliances for damage or malfunction. If the problem cannot be identified, contact a qualified fire alarm technician. False alarms can be a significant problem for fire alarm systems. They can disrupt building operations, waste resources, and create a sense of complacency among occupants. To minimize the risk of false alarms, it is important to properly design, install, and maintain the system. Use appropriate types of detectors for the environment. Ensure that the system is properly tested and maintained. Educate building occupants about the causes of false alarms and how to prevent them. Address any sources of nuisance alarms promptly. Remote monitoring is a valuable feature for fire alarm systems. It allows the system to be monitored remotely by a central station. The central station can notify the fire department in the event of a fire alarm. Remote monitoring can also provide valuable information about the system's performance, such as battery voltage and signal strength. This information can be used to identify potential problems before they become serious. A few additional points to consider during fire alarm system upgrades include: firstly, ensure the new system is compatible with existing components if any are retained. Secondly, verify that the selected components meet current code requirements. Thirdly, properly dispose of old equipment in accordance with environmental regulations. Fourthly, provide training to building staff on the operation of the new system. Fifthly, update building evacuation plans to reflect any changes in the fire alarm system.